Today we're going to be talking about rationalizing the denominator. By the end of this video, you'll be able to simplify radical expressions by rationalizing the denominator with both monomial and binomial denominators. Rationalizing the denominator should be somewhat familiar from geometry, but we are going to be adding some new aspects today. So first of all, we have two new rules for fully simplifying radicals. The first is that you are not allowed to have a radical in the denominator. Second is that you are not allowed to have a fraction or a decimal as the radicand. So far, this has not been a problem. For the first example here, if you have square root of 20 divided by square root of 2, we know that since they are both square roots, we can just go ahead and divide those numbers and end up with square root of 10. For the second example here, we have cube root of 16 divided by cube root of 2, which gives us cube root of 8, which equals 2. And for this third example, we have the fourth root of 81 divided by the fourth root of 3, which gives us the fourth root of 27, which cannot be simplified anymore. But what about this problem here? We have square root of 10 divided by square root of 3. If we try to divide them, we end up with a decimal, which we just said we're not allowed to have. So in this case, we have to rationalize the denominator. This is how we get rid of that radical in the denominator. So to do that, I'm going to multiply both the numerator and denominator by square root of 3. Because multiplying the numerator and denominator by the same thing means we are just multiplying this fraction by 1, so we're not changing the value, but we'll just change the way it looks. So when I multiply these together, in the numerator, I end up with square root of 30, and the denominator, I end up with square root of 9. Square root of 9 can be simplified to 3, so I just end up with square root of 30 over 3. Now we don't have a radical in the denominator, and we do not have a fraction or a decimal as the radicand. So let's try a few more examples. With this next example, we have the square root of 3/5. We know from the quotient property in the last tutorial that we can rewrite this as square root of 3 over square root of 5. Then to get rid of the square root of 5 in the denominator, we should multiply both the numerator and denominator by square root of 5, which gives us square root of 15 over 5. This next one here is a little bit trickier. We have 2 divided by square root of 10x. So we have a variable in here, but it's still the same idea. We're going to multiply both the numerator and denominator by square root of 10x. In the numerator, we're left with 2 square root of 10x. And in the denominator, we are left with just 10x. Now, in this case, we can simplify this fraction a little bit more. I have 2 over 10, which I can simplify and end up with a final answer of square root of 10x over 5x. This fourth example here is square root of 5 over square root of 30. You can start rationalizing now, or you can simplify that a little first. I'm going to simplify this. I know that square root of 5 divided by square root of 30 will simplify to square root of 1 over square root of 6. Then I can rationalize the denominator and deal with much smaller numbers. So now I can multiply by square root of 6 over square root of 6 and end up with square root of 6 over 6 as my final answer. If you chose to rationalize the denominator first, it would still work. You would just have much larger numbers to deal with and a lot more simplifying to do at the end. Now, what if we have binomials as our denominators instead of monomials like the previous examples? In this situation, we need to multiply by the conjugate. You should remember what a conjugate is from earlier this year. The conjugate for 5 plus square root of 2 is 5 minus square root of 2. So we need to multiply both the numerator and denominator by 5 minus square root of 2. Now, the only thing about this is that we have to remember to distribute, so we have a little bit more work to do. So in the numerator, if we distribute the 3, we end up with 15 minus 3 square root of 2. In the denominator, we have to double distribute. So if we have 5 times 5, it gives us 25. 5 times negative square root of 2 is negative 5 square root of 2. Square root of 2 times 5 is 5 square root of 2. And square root of 2 times negative square root of 2 is negative square root of 4. So we can go ahead and simplify this. The negative 5 square root of 2 and positive 5 square root of 2 cancel out. We know that the square root of 4 is 2. So we end up with 25 minus 2 in the denominator, which is just 23. And then the numerator will stay 15 minus 3 square root of 2. Let's look at one more example. In this example, our denominator is 1 minus square root of 5, so the conjugate is 1 plus square root of 5. So we're going to multiply both the numerator and denominator by 1 plus square root of 5. So we need to distribute the square root of 2 in the numerator, end up with square root of 2 plus square root of 10. And we need to double distribute in the denominator. So you have 1 times 1, which is 1. 1 times square root of 5 is square root of 5. Negative square root of 5 times 1 is negative square root of 5. And negative square root of 5 times positive square root of 5 is negative square root of 25, which is negative 5. Now, the positive square root of 5 and the negative square root of 5 cancel out. And we end up with square root of 2 plus square root of 10 over negative 4. Now, usually we don't have negatives in the denominator either, so I'm going to switch the sign of everything in this fraction and end up with negative square root of 2 minus square root of 10 over 4. So in general, you should not have negatives in the denominator. Now, why are these next couple not simplified? Well, we know that I is the square root of -1, so if we have I in the denominator, then that means we have a radical in the denominator. So we are not allowed to have an I in the denominator either. So we're going to use the same process to rationalize the denominator. We have 3 over 2i. We're allowed to have the 2 in the denominator, it's just the I that's the issue. So I'm just going to multiply both the numerator and denominator by I. That gives me 3i over 2i squared. We learned earlier this year that I squared is -1. So this equals 3i over -2. And we just discussed that generally we do not leave negatives in the denominator. So this is -3i over 2. For this next example, we have a binomial in the denominator. We have 1 minus 4i. The conjugate is 1 plus 4i. So we need to multiply by 1 plus 4i on both the numerator and denominator. And in this situation, we need to double distribute in both the numerator and denominator. So for the numerator, we have 7 times 1 plus 7 times 4i plus 5i times 1 plus 5i times 4i. In the denominator, we have 1 times 1, 1 times 4i, -4i times 1, and -4i times 4i. Remember that I squared equals -1, so this equals -20, and this equals +16. And the 4i and -4i in the denominator cancel out. Then we can just combine our like terms. So we have 7 plus -20, which is -13, and then 28i plus 5i, which is 33i. And in the denominator, we have 1 plus 16, which is 17.